Today we are going to do the last section of chapter 3, which is over exponential and logarithmic equations. So we're going to talk about how to solve these things now. And they're going to be a little bit more complicated than some of the simple ones that we've solved in the past. So what we're going to have is we're going to have equations. They may be in exponential form, they may be in logarithmic form. So we're going to kind of have to look what we have and figure out how to deal with it. So the first thing, if I have an exponential equation, the first thing I always look for is, am I able to use the same base to rewrite what I have? Because if so, then we can do something very similar to what we've done in the past, which is get our bases the same, and then we can ignore the bases and focus on the exponents. Set them equal, and we can solve. So this will be kind of the same thing as what we did before, just a little bit more involved. All right, so if we take a look at number 1, I see a base of 36 and a base of 6, and I know that both of those can be written using a base of 6, which means that the right side is fine just the way it is, so we're going to leave that alone. However, the left side, 36 is the same thing as 6 squared. So instead of 36, I'm going to write 6 squared, so that is 36. But then remember that 36 was raised to the x plus 1 power. Now, we do have the same base, but we notice that on the left we have a power raised to another power. So we have to simplify that before we can do anything else. So we keep our base of 6, but when I have a power raised to a power, think back to your exponent rules, that means that I need to multiply those two powers together, which means distribute my 2. All right, so if I distribute that 2, then my exponent is really 2x plus 2. Make sure that you remember to multiply that 2 to the second thing as well, not just the x. Make sure you distribute it all the way through to the other exponent. Then the other side will remain 6 to the x plus 6 power. Now that we have the bases the same, we can really pretty much just ignore those bases and focus on making our exponents equal. So I'm going to take my exponent on the left and say that that must equal the same thing as the exponent on the right, because if the bases are equal, then the exponents must be equal in order for the two sides to be equal. So I set my exponents equal and I can solve. I notice that I have an x on both sides, which I don't want, so I'm going to go ahead and take care of that first. I'm going to choose to subtract the x, which will give me x plus 2 equals 6, and then I can subtract the 2 to get the x by itself, and that's going to give me x equals 4. Okay, now I can always plug this back into the original problem and see if it works. So if I have 36 to the 4 plus 1 power, that's 36 to the 5th power. You can put that in your calculator. And then the right side would be 6 to the 10th power, because 4 plus 6 is 10. You can put that in your calculator, and the two sides should be equal. So as long as they are, then that means that is your answer. All right, so that one was pretty easy, and like I said, it's very similar to what we did before. We just have a little bit more complicated exponents this time. Now, number 2 is going to work the same way, because my bases right now are 1/2 and 64. Now, I don't want to write 64 using a base of 1/2, but I can rewrite both of those bases using a base of 2. So I'm going to rewrite both of them. So I know that 1/2 is 2 to the negative 1 power, and then that 1/2 was still raised to the y power. So we'll take care of that in a minute. Now 64. 64 to what power, 2 to what power is 64? So we can play with it. We know 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32, which means 2 to the sixth power is 64. So there we go. 64 is the same thing as 2 to the sixth power. So that's my 64, and then it is raised to the 1/2 power. So again, we've got a power to a power, which means we need to multiply the powers. However, I don't need to actually distribute this time because I don't have two terms in either one. So on the left side, I have a base of 2, and then that negative 1 times y is just a negative y, or you can write negative 1y if you prefer. Then on the right side, I have my base of 2, and then my 6 times 1/2 is going to just be 3. Remember that technically, this 6 is over 1, so you multiply the numerators together, you get 6. You multiply the denominators together, you get 2, and 6 divided by 2 is 3. So that's how we got our 3. Now, our bases are the same. Great. Once the bases are equal, we forget about those and focus on the exponents. We need for our exponents to also be equal. Therefore, if negative y equals positive 3, then I would technically divide by negative 1, which means positive y will equal negative 3. And again, we can use our calculator, we can plug that in and see if it works, and it should. As long as that works on both sides, then that means that that is our answer. All right, so how about number 3? So this one we might have to think about a little bit more. We have fractions for both of our bases right now, so we need to think about how we can rewrite those. So I see that I have 2 and 3 and then 9 and 4, which we know 9 and 4 are simply the squares of 3 and 2. However, they're not in the right places. So 2 squared is 4, but 4 is on the bottom on the right. 3 squared is 9, but 9's on the top on the right. So we're going to need to fiddle with this a little bit. So I'm going to say, well, if this one were flipped upside down, then that would work, because 3 squared, 9, 2 squared, 4, and they would be in the right location. So to flip a fraction, I can simply use a negative exponent. Now, I don't want to change the value, so I'm going to make it a negative 1. So to flip that fraction over, we're going to say that that would be 3 over 2, and what flipped it over is a negative exponent, so we're going to say negative 1. Now, that power, that whole thing is still raised to the x minus 5 power, so that's going to have to get multiplied by x minus 5. Or if I want to write it the way I did before, so this is the same thing as 2/3, and then that has to get raised to the x minus 5 power. So there we can see, just like on the other ones, that we will have to distribute our negative 1. So either way is fine. Now, we have to also change our base on the right. We need that base to be 3 over 2. Well, what can I do to 3 over 2 to make it 9 over 4? Well, I can simply square each number. So if I square that fraction, I'm going to get my original base. Now, so 3 over 2 squared is my 9 over 4, and then that was still raised to the 3x over 4 power. So again, we're going to have to multiply our exponents together. So that seems a little bit crazy, but the name of the game is get your bases the same. Figure out what you need to do with the exponents to make those the same base. All right, so we have our 3 over 2, and then that's going to be raised to, and we have to distribute that negative 1, which means that will be negative x plus 5. So 3 over 2 is raised to the negative x plus 5 power. And then I have my 3 over 2 on the right side that is raised to the, well, 2 times 3x would be 6x. Remember, this is technically over 1, so 1 times 4 would be 4. And so if I have, if I have 6x over 4, that can simplify. So that would really just be 3x over 2. So we're going to go ahead and simplify that fraction. So, oopsies, 3x over 2. And then we're ready to go ahead and get this simplified or solve it. So our bases are the same, so we ignore them. We set our exponents equal, and we have negative x plus 5 equals 3x over 2. All right, now if I want to solve, since I have a fraction on one side, and it's just a single term in the denominator, that means I can simply multiply by the denominator to get rid of it. So we're going to multiply by 2 here, which is going to cancel out the denominators, and then we're going to multiply by 2 on the other side as well. So that's going to give me a negative 2x plus 10 equals 3x. And now we solve. So I have x on both sides. I don't want that. Now, I'm not going to move the 3x. So I'm not going to say minus 3x because then those would be gone and I have nothing over there. So what I actually want to do then is I want to get rid of the 2x. So I'm going to add 2x to both sides. And then that's going to give me, well, those will be gone. And I have just 10 on the left and I have 5x on the right. I can divide by 5, which gives me x equals 2. And then again, we can go back up here, plug it into our original equation, use our calculator, and we should get the same thing on both sides. If we do, then that means that answer is good, and x does equal 2. Alrighty, so let's take a look at one more before we move on to solving logarithmic equations, which this actually kind of is a logarithmic equation. However, we're going to end up changing it into an exponential equation. Now, in order to do that, remember, we're going to have to change it from logarithmic form to exponential form, which means the first thing we need to do is identify our base. And because it says ln, that means our base is e. So when I go to change that to exponential form, remember, my base will remain the same, e, and then it's going to equal 2 to the 6th power, and it's going to equal x. Well, once we do that, then that's just something I can plug in the calculator. I can't do that by hand. So I'm going to simply take this, type it into the calculator and round, and I'm going to get my answer. So if we take that and plug it in, and I need to find my calculator again. So you're going to hit second ln, and that'll give you your e. So second ln, and then in your parentheses, you're going to type 6, close your parentheses, and you get that x equals 403.42, and if we round to the third decimal place again, that would be 9. So always read your directions. It might say to round to the 100th place, which is only 2 decimal places. If it doesn't tell you, then I'm going to say just do a standard 3 decimal places because that's what we generally do for logs. All right, so those are exponential equations. Now we want to look at logarithms, and you can see logarithmic equations in several forms. So we want to kind of have a plan on how to attack them. So what you want to do is look at the form that you have in your logarithmic equation and determine, okay, where and how many logs do I have? So the first one says if there's only one log on each side, then we're going to most likely, as long as the bases are the same, going to be able to cancel, and that should make our problem super easy. Number 2 says, can we make it one log on each side? So can we condense 2 logs into 1 so that we only have 1 log on each side, and then hopefully again cancel and make it super easy? If there's only 1 log in total, like the last problem we just did, you're going to change it to exponent form, which means identify the base, change it to exponent form, and then you should be able to solve it from there. So that's kind of what we're looking for. Those are going to be the main forms that we're going to see these equations in. Now, some of them can get a little bit more complicated than others, but we're going to walk through quite a few of these. All right, so our first one, number 5. So we look at how many logs we have in our problem. We only have 1 log in the entire problem. Therefore, that means that we're going to want to change it to exponent form. Now, when I do that, remember, identify your base first. So your base is 8. So we have 8 to what power? 12. And then it's going to equal whatever is right here, including the exponent. I am not going to say, oh, hey, that 3 can go here, and then I'll change it. No, it has to be, before we can change it to exponent form, it has to be log base something of whatever equals a number. It must be in that form. All right, so then that tells me that it's going to equal x to the third power. Okay, so how do I get x by itself at this point? Well, I have x to the third power, and in order to uncube something, I'm going to cube root, which means I have to do the cube root on the other side as well. So on the right side, that's going to leave me with just x. However, on the left side, that's going to give me a fraction exponent. Remember, radicals can always be written as fraction exponents. So we're going to keep our base of 8, but the 12 is going to be the numerator, and the 3 for the cube root is the denominator. So 12 over 3 is really just 4. So that's 8 to the fourth power equals x, and then hey, that's normal math. We can put that in the calculator. So if you type in 8 to the fourth power in your calculator, you're going to get that x equals 4,096. Now, for logarithms, take a look back up here. This is important. Check all log answers. Now, checking a log answer is pretty easy because to look for extraneous solutions in a logarithmic equation, what we're really looking for is to make sure that what we're taking the log of in our original equation, right here, that's what we're taking the log of, must be a positive number. It cannot come out to 0, and it cannot become negative. So once you determine what your x equals, you need to go back up and make sure that that would not have you taking the log of a negative number. So if I do 4,096 to the third power, it's going to be huge, but it's certainly not negative or 0. It's going to come out to be a positive number. Therefore, this answer is good. Alrighty. Now, how about number 6? So I only have a single log in my entire problem, which tells me that I'm going to want to change it to exponential form. However, this one is not ready to be changed into exponential form quite yet. So before we can change it into exponential form, remember, we have to have it log base something of whatever equals something. It must be in that form. Therefore, I can't have this and I can't have this. Those have to go. So that's the first thing we have to do is get rid of those things. So I want to subtract the 6 first, which is going to give me 2 times the log of 5x, and we know because there's no base written that it's an understood base 10, and then it's going to equal 18 minus 6 is 13. No, it's not. It's 12. There we go. Okay, now we still have to get rid of our 2, which means we're going to divide both sides by 2. When I divide both sides by 2, this 2 just cancels out and leaves us with log of 5x with that understood base 10, and then 12 divided by 2 is 6. Now it's in the correct form to be able to change it into exponential form. So we take our understood base 10 and we keep that as the base. Then it's going to be to the 6th power and it's going to equal 5x. Well, then we're going to take that 10 to the 6th power, which we could go ahead and stick that in our calculator and figure out what it is. It's pretty big. It comes out to be 1,000,000. So then that's really 1,000,000. It's the right number of zeros. Yes. And then that's going to equal 5x. So then to get x by itself, we divide by 5. So we have 1,000,000 divided by 5, which comes out to be 200,000 equals x. Alrighty, now check your answer though. Go back to your original equation and look at what are we taking the log of. We're taking the log of 5 times x. So we need to make sure that with our x value, this will not be 0 or negative. And it won't, because our x value is 200,000. And if I multiply that by 5, I'm simply going to get back to 1,000,000. And that is certainly not negative or 0. So then this answer is good as well. Alrighty, hopefully we're following this. So let's take a look at some more. Alrighty, so for number 7, we have another logarithmic equation that only has a single log in the entire problem, which means we know that we're going to want to change it to exponential form. So make sure you pay attention to what your base would be though. This time I have ln, which is a base of e. However, it's not ready to be changed into exponential form yet because of this -3 in the front. That's got to go. Well, since that's an understood multiplication, that means we need to divide both sides by -3. And when I do that, I get my natural log with my little understood base e of x equals a +8. All right, now that we have that log without anything in front of it, it's just the log, we can change it to exponential form, which would be my base is e, it would be to the 8th power, and that equals x. So this comes out very similar to the problem we did earlier. So we have x equals, and that's actually just something we can put in our calculator. So we're going to type in our calculator, second ln, to get our e, and then we're going to type 8 and close our parentheses. And we get that x equals 2,980 point, that would come out to be, oh, I did not give myself enough room, 0.958 if we're rounding to 3 decimal places. If we're rounding to 2, then that would be 0.96. All right, now make sure we are taking the log of x. So because we're taking the log of just x, that means x must be a positive number, which the answer we got is a positive number. So that answer is good. Alrighty, for number 8. Okay, we've got logs all over the place in this one. So think back to what we had that told us what we want to do. So this is going to be number 2. So we don't just have one log on each side, and we don't just have one log total. So we want to try to get it to where we can make it so it only has one log on each side. So if we look at number 8, can I combine the 2 logs on the right? Yes, I can, because they both have the same base. Therefore, I want to condense those down into a single log. So the left side is going to remain the same. On the right side, we're going to condense those into a single log base 4. And then we have to remember, well, what do we do with these 2 things? Well, that's based on this sign right here. Since that's a plus, that means that we are multiplying those 2 things together. So we're going to have log base 4 of 3 times x minus 2. So we can go ahead and distribute that out. So we would have log base 4 of x equals log base 4, and if I distribute that 3, not just multiply it by the x, but distribute it, we're going to have 3x minus 6. So we're taking the log of that binomial. Now, what's nice at this point is that now I have our first option. I now have number 1. There is one log only on each side, which means that as long as our bases are the same, which they are, I can actually ignore those log base 4s, because if they're both log base 4, that part is the same, then that means that in order for these to be equal, then this must come out the same. So we're going to simply focus on that, and we're going to set those equal. So x must equal 3x minus 6 in order for those logarithms to be equal. So to solve that, I'm going to subtract my 3x and get it over here with the other x. And then that's going to give me a negative 2x equals negative 6. Then I can divide by the negative 2 that's in front of my x. And then x equals 3. Okay, so we have our proposed answer. Let's go back to our original problem and make sure that it works. So we have to take a look at every original log and make sure that what we're taking the log of, so this this, and this would all come out to be positive numbers using this value of x. So if this is 3, well, that's taking the log of a positive number. Good there. Well, that's just a 3. There's no variable there, so I don't even need to worry about that one. And if I plug 3 in for x here, that would be 3 minus 2 is a positive 1, and positive is good. Therefore, this answer is great. Okay, let's keep going. Alrighty, so for number 9, so again, we have not just a single log in the entire problem, but we do have logs on both sides. However, we only have one log on each side. And because we see that they are both log base 3, well, that part is equal. Therefore, this must also be equal. So we're basically ignoring this and focusing on what it is we're taking the log of. If those two things are equal, then our logs are equal. So we're going to take x squared plus 3, and we're going to set it equal to 52. And then we're just going to solve this, just normal algebra. Now, I don't have an x, so there's no x there. Therefore, I am not looking to factor. I only have x squared, which means my goal is to get x squared by itself and then take the square root. So to get that x squared by itself, I'm going to need to subtract the 3, which is going to give me x squared alone on the left, and then 52 minus 3 is 49. Now we have x squared, but we want x. So to undo squared, we square root. And because we are square rooting on both sides, that means that I absolutely must have a plus or minus over here. Must. So the square and square root simply cancel, leaving us with x on the left. But on the right side, I take the square root of 49, which is 7, but it must be positive or negative 7, because if x squared is going to equal 49, well, if we take positive 7 and square it, we get 49. However, if we take negative 7 and square it, we also get a positive 49. So we must include that plus or minus. We technically have two answers. Now we do need to make sure that this works. If, when we plug it back into our original functions or original logs, that we don't get negative or 0. So let's take positive 7. So if I put positive 7 here, then that's going to be 7 squared is 49, plus 3, that's still a positive number. Positive 7 is good. However, if I take my negative 7 and I plug it in, is that going to work as well? Yes, because negative 7 squared would give me 49, plus 3, still positive. That's also good. And then this is only a number, so it's going to have to just be that positive number. So both positive 7 and negative 7 will work in our original logarithms. Alrighty, now number 10 is going to take a little bit more work. So first of all, look at where all of your logs are. How many do you have on each side? And we see that we have one log on the left, but we have 2 logs on the right. So the question is, can those 2 logs on the right be condensed? Yes, because they're both log base 6. So we're going to leave the left side alone for now. Log base 6 of negative 2x equals, and then I'm going to condense those 2 logs. Since they are both log base 6, I can condense them into a single log base 6. And then, what do I do with these 2 things here? Well, because it's adding, I'm going to multiply those 2 things together. Since they are both binomials, that means I actually have to distribute it all out and combine like terms. So we can always go off to the side. So I'm going to separate this off, and then we're going to go off to the side and we're going to multiply that out. So actually, maybe I'll just do it over here. Yeah. So if we have x minus 2 times x plus 1, or if you prefer, you can use the box method, whatever works for you. So we're going to have x times x is x squared. X times 1 is x. Then we have negative 2 times x is negative 2x, and we have negative 2 times 1 is negative 2. Then when we combine like terms, that gives us x squared minus x minus 2. So that's what we're going to plug in here for our condensed logarithm. So that's going to be a log base 6 of x squared minus x minus 2. Okay, now getting back to our problem, I now have a single log base 6 on each side, which means I can now ignore those and focus on making sure that what we're taking the log of is equal. So we're going to take negative 2x and say that it must equal x squared minus x minus 2. Now this one we are going to have to factor because I don't just have x squared, I have x squared and x. So I'm going to need to get everything on one side, make sure that it's set equal to 0, and then I'm going to try to factor. So in order to get everything on one side, I'm going to add the 2x to the negative x, and then that's going to give me 0 equals x squared plus x minus 2. And then I want to try to factor this if I can. And by the way, if you don't like your equal 0 over here, you can put it over here. It's the same thing. It doesn't matter. Whatever makes you happy. All right, so when we go to factor this, we know that we are going to have x as the first term in each because x times x is x squared. However, we need to figure out what multiplies to give us negative 2 and adds to give us a positive 1. So that's going to be a positive 2 and a negative 1. So doesn't matter which one comes first. So negative 1 and positive 2. Double check yourself. Negative 1 times 2 is negative 2. Check. And then negative 1 plus 2 is positive 1. Check. All right, now we set each one of those equal to 0. So if I set x minus 1 equal to 0 and solve, I get x equals positive 1. If I set x plus 2 equal to 0 and solve, I get x equals negative 2. Now I need to check both of these answers and make sure that they work in our original logs. So here, that must be a positive number after I plug in. This must come out to be a positive number, and this must come out to be a positive number. If any of those comes out to be either 0 or negative, then I automatically am going to throw that answer away, because it won't matter if it works in the others. It has to work in every single one. So if I plug 1, so we're going to start by checking our 1. Oops. So if we check our 1, I'm going to plug it in. So if I plug 1 in here, well, that's negative 2 times 1. That's negative 2. I cannot take the log of negative 2, so automatically I have to throw that one out. I don't even bother checking in the others. So we're done with that one. We know 1 doesn't work. So let's try negative 2 and see if that one works. So if I plug negative 2 in here, then negative 2 times 2 is 4. All right, that one's fine. If I plug negative 2 in here, then that's negative 2 minus 2 is a negative 4. That does not work. I cannot take the log of a negative number. So that means I have to throw that one away. And since neither of my answers would work in my original logs, then that means that I have no solution. So you can write it out, no solution, or you can simply put the 0 with the line through it, which is the symbol for the empty set, and I know that that means no solution. All right, if you don't put that slash through it though, that's just 0. Then you're telling me the answer is 0. So no solution has to have that slash through it. Alrighty, now the next thing. Okay, we're going to go back and look at some exponential equations. So in all the ones that we did, we were able to change the bases so that they were the same and then focus on the exponents. However, that's not always going to be the case. So that's where this comes in. If you are not able to get the bases the same, then you're going to take the log of both sides, because in equations, the golden rule is we can do anything we want in an equation as long as we do it to both sides. So if I want to take the log of one side, then I have to take the log of the other side. And when I say take the log, That literally just means write log in front of each side. So since 4 and 13 cannot be rewritten to have the same base, there is no way. 13 is a prime number, and 4 can only be divided by 2, so there's no way to rewrite those to have the same base. Therefore, I'm going to take the log of both sides. So I'm going to say log, and I'm going to use an understood base 10 because that gives me the option to use the calculator later. So log understood base 10 of 4 to the 2x plus 1 power. So literally all I did is put log in front of what was already there. Same thing on the other side. If I take the log of the other side, I'm going to do log, I'm going to use the understood base 10 again, of 13. So I literally just put in log in front of what was already there. Now, by doing that, I'm able to manipulate this a little bit. I now see on the left side that I have a log that contains an exponent. And I know that from my properties in 3.3 that we talked about, that anytime I have a log with an exponent, this exponent can be moved to the front of that log. So I'm going to take that exponent and I'm going to move it to the front, and I am going to put it in parentheses because I need to show that that is grouped together. That was my exponent and it is moved in front of the log, and that entire thing is multiplied by the log base 4. Which means, guess what? We're going to have to distribute. Okay, so, or maybe, we might actually be able to find an easier way. Then, we still have log 13. Okay, now, we can distribute, but I'll be honest with you, that's going to make it a little bit harder. We're trying to get x by itself because that's how we solve. And x is inside of the parentheses. So instead of distributing, we can just start getting rid of the stuff on the outside, and then once we get rid of everything on the outside, we'll be able to drop the parentheses and then start working on that stuff. Now, because that is 2x plus 1 times log 4, that means to get rid of that log 4, we can simply divide. So if I divide by log 4 over on the left side, those are just going to cancel. If I divide by log 4 on the right side, well, I'm not going to do anything with that at the moment, but we know that that's something we can type in our calculator. We don't want to do it yet, though. We're going to wait until the end. So these are now gone, which means I no longer need the parentheses. Therefore, this is just going to be 2x plus 1 equals, and then I have that fraction, log 13 divided by log 4. Okay, so now, if I want to start getting x by itself, I know I need to get rid of the 1 next, which means I need to subtract. So if I subtract that, then I'm going to get 2x equals, because if I subtract 1 here, those are gone. And if I subtract 1 from the other side, I need to be very careful. That 1 is not in my fraction. It's going to go behind it. So I'm going to have my fraction with log 13 over log 4, and then I'm going to subtract 1 from whatever that comes out to be. Okay, here's where it starts to look a little bit ugly. We know what to do. We know that we have 2x, so to get x by itself, we need to divide by 2. No problem. We know this. If I divide by 2 here, that's gone. I'm left with just x equals. Great. However, when I divide the other side by 2, remember, I'm dividing the entire side by 2, which makes it start to look kind of ugly. So we have the fraction, log 13, divided by log 4. Then we subtracted the 1, and then we divide by 2. So we need to come up with what this equals as far as a decimal. So this would be what we'd call the exact form, but we want the decimal form. And I would highly recommend that you do this in steps. So take your calculator and do log 13 divided by log 4. And so we remember that we have to close the parentheses after that 13 before we do divided by log 4. And so you're going to get 1 point something, something, something. Then, once we have this done, then we're going to subtract our 1. And so now that's going to give us 0.8502, blah, blah, blah. Got that done. Now we're going to divide by 2. And so we end up getting that x is approximately, it's not exactly equal to, but approximately, so we'll put the approximately symbol, 0.425 if we're rounding to 3 decimal places. Alrighty, so that's number 11. Definitely a little bit more tricky, but just follow what you know. Alrighty, now let's take a look at number 12, which is going to kind of follow along the same lines, but this time my base is e. So I have an exponential function with a base of e, and we cannot get e and 6 to have the same base. There's no way to rewrite those to have the same base, so we want to take the log of both sides. However, because I have e, I don't want to use log log, I want to use ln. So I'm going to say I take ln and I put it in front of each side. So I'm going to put ln in front of that e to the 4 minus 3x power that was already there. Now remember, that e that's already there is not the base for your log. There's another little understood e here. Okay? So we'll come back to that in a second. Then on the other side, you're going to put ln in front of the 6 as well. Okay, now here's why we make sure that we use ln when we see e. Because we have that little understood base e, and we have this regular base e, that tells us that ln base e and regular base e are going to cancel, which now makes my job so much easier. So the only thing that's left is that exponent, 4 minus 3x. And then that equals ln 6. Well, now I just need to get x by itself. So I would subtract 4, and then I'm going to subtract 4 from there. You are not actually doing 6 minus 4, because that's ln 6, which is some horrible decimal, and then you're subtracting 4 from it, so be very careful with that. So we have negative 3x equals the natural log of 6, so we're just taking the natural log of the 6, and then we're subtracting 4 from that answer. Then we've got to get rid of the negative 3, so we divide this whole thing by negative 3, and so then that gives us x equals the natural log of 6, whatever that comes out to be in our calculator, then minus 4, and then divide that by negative 3. So when you put that in your calculator in that order, you're going to get x comes out to approximately 0.736. So make sure that you're practicing this in your calculator and you're getting the same decimals, because if not, then you're probably putting something in the wrong order or whatever, and then you need to talk to me or one of the other PreCal teachers and make sure that you understand how to put that in the calculator correctly. Alrighty, so we have those two. So we've got just a few more. So let's keep going. We want to make sure that we have talked about most of the things that you could run into. All right, now number 13 looks really weird. So I want to talk to you about how to kind of deal with this in more familiar terms. So we have e to the 2x power plus 6e to the x power minus 16. So what we want to do is we want to, for just a moment, I want to think in simpler terms. So you're going to think that this is x, so make all of your e's x's for just a minute, and then drop x out of your exponent. So think of this as x squared plus 6x minus 16. If we see it like that, we know what to do. We say, oh, well, that can factor. No big deal. So I'm going to factor that. So if I factor that, I'm going to get x plus 8 and x minus 2, because 8 times negative 2 is negative 16, and 8 minus 2 is positive 6. Okay, so if I think of it that way, so think you're making these x's, and then you're ignoring these x's, and then it looks like something you know how to factor. Now, that's not actually what we have, but that helps you see how to factor it. So remember, our e's became x's. Therefore, we want to, so this is just what we're thinking, this is not actually solving it. We need to take those factors that we came up with from our simplified equation and put it back in terms of e. So if we made e our x's, then that means we need to make x our e's. So then this is really going to be e to the x power plus 8, and then e to the x power minus 2. So our x's became e to the x power. But other than that, the factoring is the same. Now, this is honestly the hardest part of the problem, is just knowing how to look at this thing and get it factored and then put back into e form. So we can also think of it as e to the 2x power. Well, this would be e to the x times e to the x. Because remember, when your bases are the same, you add the exponents. So x plus x would be 2x. So that's why we have e to the x here and e to the x here. Then we want to know what multiplies to give us negative 16 and adds to give us our positive 6. Well, that gives us our positive 8 and negative 2. So either way will help you get it factored. So you need to decide which one is the easiest for you to recognize and be able to do. Okay, so then let's get these, well, we're already factored, so let's get them solved. So we know that once we're done factoring, we set each factor equal to 0, and then we solve. So if I take that first factor, e to the x plus 8, and I set it equal to 0, then I take my second factor, e to the x minus 2, set it equal to 0. Now we have two little equations to solve. So x is in my exponent, so I know that I am most likely going to need to use a log to solve it, but before I can do that, I've got to get rid of the 8 and get rid of the 2. So I'm going to, for that first one, subtract 8, which gives me e to the x equals negative 8. Then, in order to solve that, I can't get those bases to be the same. Therefore, I'm going to use a natural log to be able to cancel out that e. Make sure you use a natural log on the other side as well. And this right here should set off a bell. I cannot take the log of a negative number, which means automatically I don't even need to finish solving this. I can automatically tell you that I am not going to get an answer. This cannot happen. So, since this one cannot be, that means that for this factor, there is no solution. However, we still need to solve the other factor. There might be a solution there. So for that one, we're going to add 2, which gives us e to the x equals positive 2. Well, again, can't get the bases the same, so we do ln of e to the x equals ln of 2. And then, since we have that understood e here, those are gone, which gives me x equals ln 2. And that can happen. I can put that on my calculator and I can get an answer. So when you type ln 2 into your calculator, you are going to get approximately 0.693. And so then that would be our one and only solution. There were no solutions here, therefore, that one meant nothing. This one, however, did give me a solution, so I get to keep that one. Alrighty, let's take a look at another one of those because I think that E thing tends to throw people. So I want to do one more, make sure that we're good on how to factor that. So before we factor it, we know we have to have it equal to 0. Therefore, we're going to have e to the 2x plus 2e to the x, and then we have to subtract that 8, and now it equals 0. So if we want to factor this, remember, if we're going to get e to the 2x, that's going to be e to the x and e to the x. Great. Now, I need to figure out what do I use to multiply two numbers to get negative 8 and then add together to get a positive 2. So multiply to negative 8 and add to positive 2. So that's going to give me a positive 4, and a negative 2. So double check yourself. 4 times negative 2 is negative 8. Check. And then 4 minus 2 is a positive 2. Check. So we've got them factored. Now we set it equal to 0. So the first one, e to the x plus 4 equals 0. Well, we know we need to move that 4 over. So e to the x would equal negative 4. And I'm already sensing that this is going to be a problem. So when I go to take the natural log of both sides, that gives me the natural log of negative 4, which again, cannot happen. So there is no solution for that factor. We do have to try the other factor though. So if we have e to the x minus 2 equals 0, then that gives me e to the x equals positive 2 because we add that 2 over. Do our ln on both sides. And if we've noticed, this comes out to be the same thing as the last problem. So those cancel, leaving us with x equals ln 2, and ln 2 equals the same thing here that it did in the last problem, 0.693. Alrighty, so hopefully that second one made a little bit more sense now that we've talked about it. So the big thing here is, remember, this is always just going to be e to the x times e to the x. Then you get these numbers the same way we always have. Okay, so your factoring is really pretty much the same, just that e thing. Alrighty, 2 more problems and we will be done. Okay, so for number 15, I see that I have 3 natural logs. I have 2 on one side, and because they're natural logs, that means I can combine them, so we're going to start there. So if I take those natural logs and I combine them, then I have a natural log of, and then because this is plus, that means that I am multiplying x plus 2 times 3x minus 2. So we're going to go off to the side, and we're going to multiply that out, and then we'll come back and put it in our problem. So if we have x plus 2 times 3x minus 2, or you can use the box method if you prefer. So we're going to get 3x squared minus 2x plus 6x minus 4. So that would be 3x squared plus 4x minus 4. Okay, so our condensed log then is the natural log of that product, 3x squared plus 4x minus 4. Now on the right side, I only have a single natural log. However, I have this 2 in front. Therefore, I need to move that 2. And we learned in 3.3 that that 2 can become an exponent on what we're taking the log of there. So that's actually going to be the natural log of 2x, and then that whole thing squared. All right, so then if I want to solve this, I now see that I have a single natural log on both sides. Therefore, I can now ignore the natural log and focus on what we're taking the log of. So 3x squared plus 4x minus 4 must equal the same thing as 2x squared. So not just 2x squared, but 2x quantity squared. So that means that when we want to go ahead and write this out, that means that we're squaring both the 2 and the x. So that's important, remember that. So we have on the left 3x squared plus 4x minus 4. But then on the right side, if I square both the 2 and the x, then 2 squared is 4, and x squared is x squared. Which now tells me that I am ready to finish solving this. So I see that I have x squared and x. I'm going to have to factor, which means I want everything on one side. So most of us are going to be tempted to subtract the 4x squared, and that's fine. However, we're going to have to do a little fixing when we're done. So we know this is going to give us negative x squared, and that's our problem. We don't like to factor when x squared is negative, but we can fix that. And then this is still going to be plus 4x minus 4, but now it's going to equal 0. So in order to fix it so that we do not have a negative there, because factoring with a negative x squared is much more difficult, then remember, equations, I can do whatever I want as long as I do it on both sides. So if I multiply everything in the equation, including the 0, by a -1, then I'm going to have the same equation, but opposite signs, but it's still an equivalent equation. So if I multiply everything in the equation by -1, then I'm going to get a positive x squared minus 4x plus 4, but then it still equals 0 because 0 times anything is 0. Now I can factor this pretty easily. So I know that I am looking for two numbers that are going to multiply to give me a positive 4 and add to give me a -4. And that's actually going to be -2 and -2. So I get the same factor twice, which means I'm going to get the same answer. So I really only need to set one of them equal to 0. So if I set x minus 2 equal to 0 and solve, that gives me x equals positive 2. Now, we do need to make sure that this works because it's a logarithmic equation. We need to make sure that if I plug 2 in for x, then I'm not going to get negative or 0 in any of these things that I'm taking the log of. So in the first one, if I plug 2 in here, well, 2 plus 2 is 4. That's positive. That one's great. If I plug 2 in here, 3 times 2 is 6, minus 2 is 4. It's positive. That's great. Then if I plug in 2 here, 2 times 2 is 4. Great. So this answer is perfect. Alrighty, and our last problem, I know this has kind of been long, but this is our last problem. We have two logarithms, but they're on the same side. Now, our temptation for a lot of us is to say, well, can't I just take one of them and move them over here and then I'll have a log on each side? Well, if it wasn't for this 2, then that might possibly work, maybe. However, even if I did that, I would have a negative, so that probably still wouldn't work. So what we have to do then, since we have the log on both sides, or so we have two logs on one side, we want to condense them. And in order to be able to condense them, our bases must be the same, which they are. So we're going to go ahead and condense those down to a single log base 12. And then because we are adding the two logarithms together, that means I need to take the 12x and multiply it by the x minus 1. So if I multiply those together, then 12x times x is 12x squared. And then 12x times -1 is a -12x. So there's my combined log, and that is supposed to equal 2. So now I only have one single log in the entire problem. And so remember we said if you have one log in the entire problem, we're going to change it to exponent form. So that means we need to keep our base as 12, but then that 12 is going to be raised to the second power, and it's going to equal the 12x squared minus 12x that we were taking the log of in the step above. Okay, well, 12 squared, that's just 144, so let's change that to a normal number. And then we can see that we have both x squared and x. Therefore, we're going to need to get it equal to 0 and then factor. So if we get it equal to 0, we're going to have to subtract the 144. So we're still going to have our 12x squared minus 12x, but we're subtracting the 144 to move it over. And now we have it set equal to 0. Now, looking at this, I think at first glance, this is going to be horrible to factor. However, look at all the coefficients. They can all be divided by 12, which means this is actually going to make our job much, much easier. So I'm going to divide every single thing by 12. And then I'm going to get a very nice problem to factor. So I'm still going to have 0 equals, and then that's just going to give me x squared minus x, and then minus 12. And now, like I said, that is much easier to factor. So I'm looking for two numbers that multiply to give me -12 and add to give me a -1. And so if I do x minus 4 and x plus 3, we should be good. Because -4 times +3 is a -12, and -4 plus 3 is our -1 in the middle. So we're good there. Now we need to solve these and then make sure that each answer works. So for our first one, if x minus 4 equals 0, that means x equals positive 4. Then if x plus 3 equals 0, that means x equals negative 3. So we need to check each of these answers. So let's start with 4. We're going back up to our original problem, and we need to make sure that when we plug in our answers, that this comes out to be a positive number and this comes out to be a positive number. So if I plug in 4 here, that's 12 times 4, 48. That's positive. Great. We're good there. If I plug in 4 here, 4 minus 1 is 3. That's a positive number. We're good there as well. Therefore, this answer is fine. Negative 3. If I plug in a negative 3 here, 12 times negative 3 is a negative 36, and I cannot take the log of negative 36. Therefore, I don't even need to check the other one. I automatically am going to throw that one away. So the only working answer that we have for this last problem is just x equals 4. So we have our plan of action. Look for how many logs you have and where they're located, and that gives you an idea of what you need to do. So remember, if we have, where's that slide? Here we go. If we have one log on each side and they have the same base, then we can cancel out those logs. Just make sure that if there's anything in front, you've already moved it up to an exponent, or if there's anything added or subtracted, you've gotten rid of it, or whatever you need to do. But if you've got one log on each side and they have the same base, you're going to get it to where you're ready to cancel those logs and set the rest of it equal. If you can make it to where you have only one log on each side, so condense, then again, you can cancel those logs and then solve. However, if you have one log total in the entire problem, or you have to condense it on one side to where you only have one log on one side, then you're going to change it to exponent form and then solve from there. Now for your exponential equations, remember, for exponential, you are going to try to get the bases the same. And then, if you can, then you're going to ignore the bases once they're the same, and then you can set the exponents equal. So try to get the bases the same and set exponents equal. If you can't get the bases the same, then, so that, if not, then you're going to take the log of both sides. Okay, so that is our general plan of attack for solving. And remember, for logarithms, always check, because you cannot take the log of negative or 0. Alrighty, so that is it for Chapter 3.